When you stand at the edge of the ocean, have you ever really thought about where it all came from? I don't just mean the waves, I mean all of it, the water itself. Well, the answer is this incredible story, and it starts both deep inside our planet and way out in deep space. I mean, just look at that. It covers over 70% of our world. It's this massive, powerful force that literally shapes our planet. So that's what we're going to do today. We're going to go on a journey all the way from the fiery birth of our water world to the ridiculously complex and fragile life that's just below the surface. Okay, so to really get this, we can't start with the Earth we know and love. No way. We've got to rewind the clock. I'm talking way back, more than 4 billion years, to a planet you wouldn't even recognize. So picture this. A young Earth, basically a ball of molten rock and fire. For millions and millions of years, you've got these massive volcanoes. And they're not just pumping out lava. They're breathing out tons of superheated steam, water vapor that was trapped deep inside the planet. And at the exact same time, you've got a delivery from space, a constant bombardment of icy comets. Think of them as cosmic snowballs, just leftovers from when the solar system was born, slamming into the planet and instantly turning to steam. Okay, so we've got all this water vapor, but why did it end up in these huge specific spots? I mean, why isn't the whole planet just one shallow ocean? Well, the secret is actually in the rock beneath our feet. Turns out, Earth has two totally different kinds of crust. The stuff that makes up the continents, it's thick, but it's also kind of lightweight granite. But the ocean floor, that's a whole different story. It's much thinner, but it's way, way denser. And that dense rock is called basalt. Because it's so heavy, it naturally sinks lower into the Earth's mantle. It's kind of like putting a bowling ball on a soft mattress. It just creates a big dip. And that simple fact of geology, that simple difference in density, created these massive depressions. They were the perfect natural containers for all that water from the volcanoes and comets, which just slowly filled up over millions of years, and voila, you've got oceans. All right, so we've got our giant bowls, and they're full of water. But what's so special about this water? What's the secret sauce that makes life possible? Well, to figure that out, we have to look at the chemistry of seawater itself. If you took a gallon of seawater and just boiled it all away, you'd be left with this really specific mix of salts. Yeah, about 85% of it is just regular old table salt, sodium chloride. But here's the wild part. The proportions of all these salts are pretty much identical in every single ocean on the planet. It's called the principle of constant proportions. And what that means is that life in the ocean, no matter where it is, has evolved in this incredibly stable chemical world. And why is that? Well, it all comes down to the humble water molecule H2O. It's kind of like a tiny little magnet. It's got a positive side and a negative side, and because of that, it can just swarm around other molecules like salt and literally pull them apart. It's an amazing solvent. And it's this incredible power to dissolve stuff that, over billions of years, has washed all these minerals off the land and turned the ocean into this rich chemical soup that's just perfect for life. And look, this isn't just some boring chemistry fact. It is the reason, the fundamental reason, that incredible ecosystems like this coral reef can even exist. All those dissolved bits and pieces, the salts, the minerals, the gases, they're the building blocks for life. They fuel the whole shebang, from the tiniest little plankton all the way up to the biggest whales. But here's the thing, the ocean is never, ever still. It's a restless, constantly moving system. It's basically a giant engine, driven by these huge forces that are always stirring up that global soup, and in the process, shaping the climate for the entire planet. And the power source for that engine? It's the sun. It's pretty simple, really. The sun blasts the equator with way more heat than the poles. That creates a huge temperature difference. Hot air rises, cool air sinks, and this whole process kicks off these giant, predictable loops of circulating air in the atmosphere. And those loops, that's where we get our global winds, the ones that sailors have relied on for centuries, like the trade winds and the westerlies. Okay, so you've got these winds blowing across the water, and they're literally just transferring their energy straight into the ocean. It starts small, right? Just little ripples from the friction. But when that wind keeps blowing over a huge stretch of open ocean, sailors call that the fetch, those little ripples grow and grow into a messy, choppy sea. Then, once the waves get away from the storm that made them, they start to organize themselves. They sort themselves by speed and turn into those beautiful, regular, rolling waves we call a swell. And the final step? As that swell gets close to shore, the bottom of the wave starts to drag on the seafloor and slows down. But the top keeps going, and that's when it curls over and crashes. That's your breaker. Now, every once in a while, something really crazy happens out there. You get swells from different storms traveling across the ocean, and they happen to meet at just the right place at just the right time. When their energy combines perfectly, you get a rogue wave. And this isn't a tsunami, it's something different. It's just a sudden, freakishly huge wall of water that seems to come out of nowhere. It's just a terrifying reminder of how powerful and unpredictable the ocean can be. Okay, let's pull this all together. We've got the stage, right? The geology of the ocean floor. We've got the medium, which is that unique chemical soup of seawater. And we've got the energy, the physics of the wind and the waves. So, how do all of those pieces, geology, chemistry, physics, combine to create one of the most stunning masterpieces in the entire natural world? This is it, the coral reef. People call it the rainforest of the sea, and for good reason. It's just bursting with life. But the craziest part is what it's made of. Those aren't rocks, and they're not plants. They're actually massive structures built by trillions of tiny little animals called polyps. Each one of these little guys builds a tiny limestone cup to live in. And over thousands and thousands of years, the skeletons of all those past generations build up, one on top of the other, creating these gigantic structures. Some of them are so big you can see them from space. It's incredible. The way an atoll forms is just a perfect story of this slow-motion dance between geology and biology. So it starts with a brand new volcanic island. Coral starts to grow all around its edges, right in the shallows. But then, over thousands, even millions of years, that volcano starts to slowly sink back down into the Earth's crust. But the coral, it doesn't sink, it just keeps growing, always reaching up towards the sunlight. And eventually, the entire island disappears beneath the waves, leaving behind this perfect, spectacular ring of living coral just sitting there in the middle of the empty ocean. But this whole amazing structure, this whole vibrant city, is built on a really delicate partnership. You see, the coral polyps themselves have these tiny little algae living right inside their tissues. The algae make food for the coral from sunlight, and in return, the coral gives them a safe place to live. Oh, and the algae are what give the coral its incredible colors. It's a perfect team. But if the water gets too warm, the coral gets stressed out and it actually kicks out its algae partners. And what's left behind is just its white skeleton. That's coral bleaching. And if things don't cool down fast enough, the coral starves to death. The whole vibrant city just becomes a silent white graveyard. So you think about it, from cosmic dust and icy comets all the way down to the tiny, delicate life inside a single coral polyp. The story of the ocean is the story of our planet. For billions of years, that story was written by things like volcanoes, comets, and waves. But now, for the very first time in Earth's history, a single species is holding the pen. And this question, it's not some abstract thought for the future. It's for us, right here, right now. What are we going to write in the next chapter?